Okay, so let's get into it. Today we're doing a deep dive on a very specific piece of hardware. It's the Aurora Multimedia RXS-2-I514-1T16G. Bit of a mouthful. Let's just call it the RX2-2 NUC PC. And this is not your average mini PC, right? This is built for some pretty demanding professional AV work.
Oh, absolutely. Our mission here is to look past the spec sheet, and really figure out why they made these design choices. What's the specific job this thing is meant to do in, say, a digital signage network or an AV over IP setup?
So let's talk about the engine under the hood. It's
Yeah.
packing a 14th gen Intel i5 plus 16 gigs of RAM and a full 1 terabyte SSD. I mean, for a box this small, that's a lot of power.
It really is. And that 16 gigs of RAM, that's not just a random number.
Right. I wanted to ask about that. Why is that the sweet spot?
Well, it's all about balance, especially with thermals in such a small chassis. You get enough headroom for the OS for real-time signal processing, all that I/O, without causing heat spikes. For AV over IP, that i5 has to handle PTP, the packet timing protocol, to keep everything in sync. And that takes some real processing grunt, not just simple data access.
Okay, and this is where it gets really interesting, I think. This isn't just an output device. You get two 4K 60 HDMI outputs, full 4.4.4. But the kicker is the HDMI input. It can capture 4K signals, too. It's an integrated capture and output box all in one.
That's a huge deal for integrators. I mean, you're saving space, you're saving complexity, probably saving on licensing costs, too.
Instead of a two-box solution or some clunky USB dongle.
Exactly. And let's talk about that 4.4.4 spec for a second.
Right, because a lot of commercial stuff is 4.2.0 just to save bandwidth.
It is, and that's fine for, watching a movie. But if you have sharp text or specific brand colors on a digital sign,
It gets fuzzy. You lose that color detail.
you get that fuzziness, that artifacting. So 4.4.4 is non-negotiable for high-end video walls or like corporate dashboards. It keeps everything crisp.
Makes sense.
And of course, the whole point of this NUC form factor is that it's small. You can hide it anywhere.
Right, tuck it behind a display or under a table. But then, how do you manage it if you can't even see it?
That's the million-dollar question, isn't it?
And the answer seems to be connectivity. You've got Wi-Fi 6E, Bluetooth, multiple LAN ports. But the thing that really stands out to me is that little OLED on the front.
Yes, that little screen is, it's a game changer for installers. Because when it's tucked away in a rack somewhere, you can just walk up and see the IP address, the MAC address.
No more plugging in a crash card, a keyboard, a monitor, just to find out its IP.
It saves so much time on a big deployment, a huge efficiency boost.
And there's one last piece here, and it's about the money. The specs say it's tariff-free and TAA compliant.
Which is huge for certain projects. TA compliance means it's made in the US or an allied country. You absolutely need that for a lot of government contracts. Federal, defense, education.
So if you're bidding on that kind of work, it's not a nice to have, it's a requirement.
It's a prerequisite. So when you put it all together, what you have is this really specialized tool. It's powerful, it's built to capture and output high-res video at the same time, and it solves the physical integration problems of space and complexity.
Okay, so wrapping this all up, here's a final thought for you to chew on. This system is clearly focused on mission-critical wired AV over IP.
Yeah.
With its multiple LAN ports. So why the heavy emphasis on Wi-Fi 6E? Is that really there for redundancy in a live environment, or is it more of a practical tool for, say, initial setup where you might not have a wired connection ready to go just yet? Something to think about for your next specialized build.